All right, so off we go. So the first three, you can see the little warm up. This is what we spent 3 days on. It's in large part what you did for homework last night. It's really the three things you need to be able to do. If I give you standard form and we have a coefficient of 1 in front of it, that's probably the easiest, nicest type that we've done. If I give you standard form and there's something other than 1 in front of it, we need to make it a 1. So in this case, it's a 4. And then the last thing that we did with all of these is we put a negative in front of it. So be able to handle all three of those tomorrow. Okay, you'll certainly get one of each of them. So make sure we're all good, or we're good with all of them. The first one we did was number 1. We were pretty good at this. What we did is we just took our x squared minus an 8x, and we tried to make a perfect square out of that. When we started all of these, we were still drawing those little rectangles, and I'll probably still draw plenty of them today. But we wanted to make a perfect square out of this, where we talked about how if I have an x squared, that's because I have an x and an x here. Can you see that, Andre? Let me move this down a little bit for you. And then I would have had, if it's a negative 8 as the middle term, that means I had a negative 4x here and a negative 4x there. So that told us we decreased by a 4. And then the negative 4 times a negative 4 gives us 16. So it's the 16 that makes a perfect square. So that's what we're adding here. That's what makes a perfect square out of those terms. And then what we said we now need to do to account for the fact that we just added a 16 out of thin air, we're going to subtract 16 on the back side there. We can then put that into vertex form. We can look over here. We have x minus a 4 multiplied by an x minus a 4. So instead of writing that twice, we just write it as x minus 4 squared. And then the 20 minus a 16 is a positive 4. From there, our vertex, we can now look at this hopefully. Actually, write that down real quick. This is something we all, I think 100% on our last quiz when I gave you a vertex form, we all had that down. So make sure we can still do that. So confident, I don't need to call on anybody. Pretty sure we will all get that right. Positive 4 is our vertex. It takes on the opposite sign of here. So the fact that's a minus a 4 means your x is positive 4. And whatever the back number has for its sign, it's going to be the same sign in your vertex. Okay? And I think we had that down pat pretty well. Oh, wait. Sorry. The vertex is 4, 4 down here. I should read my own directions on the paper. The vertex form is the equation. We already had it written, so it's just the equation we found earlier. The axis of symmetry is a vertical line. So please write this as x equals 4 tomorrow. We want to draw a cheap, quick sketch of this for the domain and the range. So up here, as long as I know what my vertex is, which we do, it's the 4, 4. Just come over here to the general area where positive 4 would be. Put your vertex, put a little dot. Since I have a 1 in front of all of this, so that's the number in front, it's positive. That tells us our parabola opens upwards. So as long as we know we have a parabola that is opening upwards, that should be plenty for us to define our domain and our range. Just a quick little sketch would allow that. Domain-wise, we're going left and right forever. We've been doing this for a couple of weeks now. Every domain for every parabola we have done up until this point. I haven't changed that yet, so we're still going left and right forever. The range is the smallest y value to the largest y value. If we look at this point, the smallest y value that this would ever hit is right here, and it's the y value of 4. And then since we go up forever, our upper limit is infinity. Okay, hopefully we're pretty good with all that. Eventually what we then did, and this took a little while for us to get, but we spent 3 days on it last week. I guess I'll look on the homework soon and see how we did with the homework. We started putting numbers in front of the x squared. That's not a 1. we start this the same way. We're going to make perfect squares. We're actually going to make 4 perfect squares out of the first 2 terms and then deal with the 80 at the end. So the x squared has a 4 in front of that. We don't want that to be in vertex form. It needs to be a 1. So we're going to pull that out, put it in front of the parentheses. The only thing left over for the first term would have been an x squared. Plus, the next spot should be whatever I would multiply by 4 in order to get the 40. So that should be 10. You can check this real quick. If I did 4 times x squared, I better get the first term. And if I do 4 times 10, I better get the second term. If that's the case, then we pulled it out correctly from those 2 numbers, okay? All right, from there, just like the previous problem, we want to know what would make this a perfect square. So what are we going to add right here? All right, so throw down what you think would go right there. All right, if we did this little model up here, right, if we drew another little area model, we would have had 10 x's that would have gotten split up into 2 different corners to be 5. And then those 5 would have been multiplied together to give us 25. So if we actually drew this out, we get a square that has a 25 right here. However, this is telling us we actually get 4 of them. So we would actually have 4 different squares with a 25 on the lower right-hand corner. So what we really have is 100. It's not just 25, it's 4 25s. And the way we know that, if we don't draw it out, is we just do what's 4 times 25, that's 100. So it is 100 that we need to be subtracting away from that 80. All right, from there, we can put this in vertex form. You're going to have your 4. What this is an x plus a 5 multiplied by an x plus a 5 on each side of our square. And then 80 minus 20, or 80 minus 100 is a negative 20. All right, so from there, that is vertex form. So let's go ahead and write that. And then real quick, fill in those next 4 things. Tell me the vertex, tell me the axis symmetry, the domain range. We spent so much time doing what we just did last week. We haven't had to do these couple of things in a little bit. So just see if we remember how to do those. All right, let's see what we got here. Maddie, what do you think for our vertex, Maddie? Good. So vertex, negative 5, negative 20. Dahlia, what's our axis of symmetry?
X equals negative 5.
x equals a -5. Our domain, Brooke, what do you think for our domain, Brooke? Good. -infinity, comma, infinity. And for the range, before I call on somebody, just to make sure you know where this is coming from, we know our vertex is a -5, -20. So if I come over here to -5 and say this is a -20, this is my vertex. Since we have a +4, that tells us this parabola would be opening upwards. So it looks roughly like this. That should help with our range now. All right, anybody want to volunteer on this one since this is the one that's a little harder? Are you feeling good? All right, Alexis, what do you think, Alexis? Close. Your range, though, is your y values. So what's the smallest y value on that? Because the y's do this. No, the -5 is our issue because that's an x value. Right. Yes, -20 to infinity. Okay, good. So our y value, the smallest y value is -20, and then we go up forever. Okay. All right. So be able to do it if there's just a 1 in front of it. That was number 1. If there's something other than a 1 in front of it, like a 4. And then the last case that we certainly want to be able to do is if there's a negative in front of it. So that's our number 3. Similar to the last few, we want to make a perfect square out of the first 2 terms and then adjust the constant at the end. Oh, you can't see that, Andre. There we go. We want the number in front of our squared term to be a 1. It kind of is, but it kind of isn't. It's currently a -1, and we don't like that. We don't want that. So we want to pull out a -1. And then now our x squared becomes a positive that we want it to be. Then you have to think for this next term here, a -1 multiplied by what would give us this +6? That would have to then just be a -6. So pulling out a -1 really just changes the signs of both of those terms. All right, do this guy real quick. Fill in this to make this a perfect square. What are we going to add right there? All right, I hope we are good with this. Since there are 6 x's total, those are the ones that we split up into 2 different boxes to get 3. And then we would have had the 3's get multiplied by each other. So that should have been a 9. So again, just to kind of understand where this is coming from, if we had set this up, we know we have our x squared here. That's the x and the x. Then -6x would have meant we had 3 here, 3 here. So that if these are both now -3's, that's a 9. So the 9 makes us a perfect square. We only have one of them in this case, so that's nice. Your issue, though, is it isn't just a 9, it's a -9 here because of the -1. So what we would said we were going to do, now I can't space it here, we have to subtract away. So I'm going to do minus whatever we've just created, which is a -9, which means ultimately we're going to be adding 9. And then what we had in our square before I erased it was an x minus a 3 times an x minus a 3. So we just write that as x minus 3 squared. And then plus 8. All right, any questions before we move on from that? You'll certainly get a negative tomorrow. There's no way I'm not going to give you that quiz without giving you a negative in front of it. Yeah, Alexis? On here or over the first one or the second one? Yeah. All right, so if I go back to the previous question here, Are you cool with how we're getting this 25? Let's see if I can just do that. Yeah. How we're getting this 25? Are you good with that?
Yeah.
All right. So what that is giving us, let me create some space here. It's telling us that if we actually made a square with a drawing, that this constant part is a 25. All right. Well, what this is now telling us, this guy out in front, means we have 4 of them. So if I drew in 4 of them, here's a 25, 25, 25. So isn't that really 100? The way we're getting that is we're doing this for, let's say I don't want to mess around with graphing all of this. I really can just do 4 multiplied by whatever makes a perfect square. I know I have 4 of those. And then don't we on the back end subtract the 100? Over here, when I added 16, didn't I then on the back subtract 16? So if we go to this guy, if I can get my computer to move, there we go. If we're going to add 9, so now just be careful here a minute. If I add 9, aren't I supposed to subtract 9 back here then? Yeah. The issue with this one, though, is that that's not just a 9. If I actually distribute, so negative 1x squared, negative 6x, isn't a negative 1 multiplied by the 9 really a negative 9? So I am still, just like we did on those previous couple of questions, I am still subtracting whatever we just created. And this isn't just a 9 because it's getting distributed by the negative 1 out in front. So I'm really distributing and creating a negative 9 out of that. All right, does that make sense?
Yeah.
Okay, and then that's why ultimately we're going to be adding 9. Okay. Okay, from there, let's go ahead and do this. I think we're good. Get to some on the next page. Oh, crap. Vertex form is this. I'm going to rewrite it. The vertex itself is 3, 8. The axis of symmetry is the vertical line x equals 3. All of our parabolas right now are going left and right forever. Let's do a cheap graph real quick so we can do the range. Plot your vertex. So here's our vertex. So we'll say here's the x value of 3. Here's the y value of 8. So we plot that point, 3, 8. Now, isn't this a negative in front? So now we know this parabola has to open downwards. So just draw a quick little sketch of this guy opening downwards. This is the range that last time we did do this, and I gave you one of these, some of us had a hard issue in terms of how you're writing it. It's always the smallest to the largest. The largest is 8. 8 is the biggest value that this graph will ever hit. So that has to go second. So it's after your comma. And then if I ask you what's the lowest value that that graph ever hits, you should say it doesn't really ever hit a low value, right? It just keeps going down, 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 down. So we just start this with a negative infinity. That's what we would start that range off with. And then we go up to 8. All right. So a big part of last week was just, I think all last week, because we didn't have school Monday, Tuesday. And then Wednesday, Thursday, Friday was just spent on those 3 types of problems. Okay. So what we now need to do, and this is what the next section is, put this together with some of the things we were doing before Wednesday, Thursday, and Friday of last week. So all this task is just a review. It's putting a lot of these ideas together now. So what you're supposed to do in all of these problems, and we'll jump around a little bit, we'll try to make sure you see enough. You're supposed to do 3 things. So if you look at number 1, we're supposed to come up with a vertex form, a standard form, and a graph. Well, you're going to be given one of those 3 things. You've got to come up with the other 2. So if you look at number 1 here, if I give you this equation, what I've just given you is the standard form of that equation. So we've got this taken care of. So the 2 things we now need to do is come up with the vertex form and then graph it. So the vertex form is what we just got done doing on the previous page. So I'll give you a minute. See if we can now do that with this problem. So work your way through that, complete the square, put it into vertex form, and see what we get. If you finish and you're confident, you know what you're doing, you did it correctly, we are going to graph this one because I haven't had you actually do the nice graph with the vertex points on each side, the XY chart. So if you wanted to kind of get started on that to see if you remember, you can do that while we wait for everybody to get this done. All right, I'm going to see where we are at here. So what we've been doing, we're going to make a perfect square out of the first two terms because it's unlikely the -3 makes this a perfect square. So we're going to make it a perfect square. So if we had done our perfect little square over here, we would have had the x squared here. The 6x's would have gotten split up evenly with 3 here, 3 here. So hopefully what would make this a perfect square, you put a +9. And then what that means, since we just added a 9 to that, we're going to subtract it on the backside. Vertex form then, what we have, this is a x, this is a -3, this is an x, this is a -3. So we have an x minus 3 here, you have an x minus 3 here. They get multiplied together, so we just write it as an x minus 3 squared. And then we should have a -12. Okay, so hopefully we got that. I then want you to now graph this. So now you have to come over here, 1, 2, 3, and then this is a little bit off the graph. So bad planning by us here, but 312 should be down here, or 3 -12. This one I do want you to graph because we haven't had to do it in a while. We were pretty good at it when we had to do it. But this is now where we're going to go ahead and set up our XY chart. We always wanted the middle point. That's always our vertex. So we can now, by putting it into this form, we can look and see what our vertex is. So we now know what that is. It's the 3 -12. That's how we plotted the first point. That's how we can start our table. And then what we said is, whatever is after it, so I'm going to pick 4, will give us the same exact value as the 2 that's in front of it. Now, you had your calculator too. I mean, you could graph it, use your table. But what we're just doing is I'm going to take this 4, and I'm going to plug it in for x into this equation. So I do 4 minus 3 squared minus a 12. So that's really just 1 squared minus a 12. And 1 minus 12 should give us a -11. So when I plugged in 4, I get a -11. So I go to my table, I can fill that in. And then when I plug in 2, I also know that would give me a -11. So go to your graph. We're still just a little bit off of this graph here. So we're going to be here and here. And then we need one more set of points. We wanted 2 points on each side. So the next one I'm going to pick is 5. Whatever I get for 5 should be the same thing I get at 1. We go back to the original equation where you have your x, plug in a 5. 5 minus 3 is our 2 squared. That then just gives me a 4 minus a 12, so that should be a negative 8. That means the 1 is also a negative 8. We can now plot those points. And then we have our graph like I'm asking you to graph it. All right, with 2 points on either side. Okay, next one. Haven't had to do this in a little while, but I'm giving you the graph. So we did this. This is on your last quiz, but we just haven't had to do it. And we want to put it into vertex form. So here's what vertex forms looks like when we don't know what our numbers are. It's the A, the H, and the K. The key with these is understanding what was our vertex of this. And so if we look at this parabola, here's our vertex, and the vertex is a negative 4, 4. So what that allows me to then do is come over here. All the H's, that's the x coordinate of our vertex. So you just plug in the negative 4 for H. And then the K is the y coordinate of your vertex. And so if this is our K, in this case, that's the negative or the positive 4. So we then do a plus 4 back here. We end up having an x plus a 4 inside. But what we still don't know is our A. So we have to figure that out. So the way we did that, notice these other points that we have. We have a point here, a point here, here, and here. We now need to pick one of those 4 points. It doesn't matter which one you pick. And we have to plug that in for x and y. I'm going to pick this point just because it has a 0 in it. That's the point 0, negative 4. But you could pick any other point and just test yourself, and we should get the same answers. So now what I'm going to do, notice where I have a y right here. Well, the y coordinate of that vertex is a negative 4. So I'm going to plug the negative 4 in for the y. So there's that. The A is what we're solving for. Then we come across our x. So the x that I need is right here. So that's our 0. So we plug in the 0 there. And then add our 4. This is just 4. You're going to square the 4 to get 16. So that really just becomes a 16a. And then plus the 4 that's still kind of hanging out at the back. Subtract the 4 from both sides so that this will go away. And we now get 16a equals a negative 8. It's interesting. How did that happen? Crap. And so 16a equals a negative 8. Divide by 16. These cancel to get our a to be a negative 1/2. All right, so then from there, we can now go ahead and plug this in with all the parts that we need. So this then, now that we know what our a is a negative 1/2, x plus 4 squared, and then plus 4. Okay. All right, how are we behind in this class? One of the technical issues last period. I don't know what happened. Okay, the next one I want you to hop to, we'll come back. Yeah, there's something else we wanted to do there, but let's do one more so at least we can answer these questions tomorrow. If I give you vertex form, be able to graph it, okay, make sure we can do that. And then just go to number 5. fill this in for me. Write this equation in vertex form. So just see if you remember where all this comes from. Doesn't make sense. Can you see that, Andre? There you go. All right, we're under a minute, so I'm just jump to it. There's really no work here. The A gives us our stretching and compressing. So the fact that you're told that you've compressed by 1/2, that's just me giving you the A. Then you're going to do X minus. The H is just the X coordinate of our vertex. So you're going to plug a -2 in right there. And then the K is the Y coordinate of your vertex, which would just be a -1. You can write it as plus a -1 if you'd like, but what that really then just means is we're subtracting 1 on the back. We should ultimately end up with X plus 2 squared. Okay. Okay. Bell's going to ring any second now. 2 things. Make sure the homework gets uploaded if you haven't done that yet, to make sure you get your points for that. And then you have a quiz tomorrow. So just look this over, look this stuff before over. If you have any questions, see me second period during intervention. Okay, I'll be logged on, or Mr. Kubowitz, he'll have his site, and then we can answer any of your questions. Okay? All right. See you guys. Have a good day.
Bye, thank you.
Guess I'm not going to ask them to do that on the quiz tomorrow. Standard form. We haven't done it a ton, so I'm okay with it. But I don't know either. No. Yeah. I don't know. See you, Andre. Good to see you. I just don't want to do another day on it. Like, we got to move along at some point.